is an update to the outdoor radiator setup. I just wanted to go over the new components, the upgrades that I've done, and we'll do some benchmarking as well, so stay tuned. So I have removed the previous setup and I removed the 360 millimeter double thickness radiator from the inside of the computer and I moved it outside. I put 3 server fans at the bottom, which are basically similar fans, and then I cleaned up the 480 millimeter radiator since it's been not cleaned since 2022, and then I put 4 server fans. The left side 2 fans are 550 CFM each, and the right ones are about 250, 300 CFM each. They're metal capped, so they're pretty good fans. These 2 fans are online with all the other ones. The other 2 fans are just war emergency power, so they don't run unless I have the kill switch on, which I'll show. It's a secondary kill switch on top of the other ones that I'll show. All right, so we're back in the room. So right now we don't have any fans running. I have a kill switch for the internal fans, and I have a kill switch for the external fans. And I will go over some of the parts in a second, but I wanted to show the top side of what the radiators look like. So the 360 mil rad does not have any fans on the top yet. I might add 3 of the identical fans on top, so it's a push-pull, which would be very nice. I used carbon Kevlar on this side, and I used carbon fiber on this side. So we have 77 CFM each fans on the top. Those also run at full speed at all times. They're not super loud. And that's the setup from the top side view. I updated the electrical system for it. I redid the wiring so it's a bit less of a fire hazard and a little bit more efficient. I replaced the power supply with this EVGA 430 watt that actually has a fan and does not get limited by overheating with the fan power consumption. So that's all handy dandy. Also looks nice, it's black. So what I did here is I made an external fan kill switch, so turn that on, and then it kicks in. And then I use the same type of switch on here. It used to be a plastic switch, so now if I do this, there you go, and it feels really nice. So that's the electrical side of things. I set the fan speed so that they're not super loud, so they're all tuned and not loud. And in a second, I will show you what it sounds like at full speed. Okay, so these are still running on the quiet PWM throttle signal. I'm not gonna touch those. They don't get super duper loud. I mean, they're still quite loud. They're server fans, but I have these 4 at the bottom set so that they're full speed, and basically that's 600 CFM plus 1100, so that's 1700 CFM plus 77 CFM each. So this is what it sounds like. Kind of cool. On to the internals. So that 360 millimeter radiator used to be in here, so I removed that. So we're only running 2 radiators right now, but the temperatures seem to be better, so that is all nice. I cleaned out the pump and reservoir, and then I fixed this pump and reservoir, so we're back to 2,500 liter per hour flow rate, and basically it's an all-wheel drive setup. So this pushes out the water, that cycles it through the radiators, that comes back through this radiator, fills the main pump, and that pump directly first pushes into the graphics card, then the memory block, and then the CPU, and then the top radiator. So this basically is pulling a vacuum, that is pushing, and it flows very, very nicely. As you can see, the flow rate is insane. This actually vibrates. You can actually feel the flow. Okay, so now on to some tests. Now I didn't have any of the fans on for the last hour, so let's see what water temp is. So we're at 23 degrees Celsius. Let's give it about 5 minutes so that the outdoor radiators kind of cool the water. The internal fans are still off so that this kind of insulates the water loop. So let's give it about 5 minutes. Look, it already is dropping. Let's give it about 5 minutes and then we'll run some tests. All right, so it's been 5 minutes and we are down to 17 degrees Celsius. Now for a reference point, the outdoor temperature, it's nearly 4 o'clock right now, so the weather is pretty warm for the day, but it's 17.9 degrees Celsius outside. And we have a 18 degrees Celsius water temp. Now, obviously, that is because we have high flowing fans. We gave it a lot of time with no load, so we have a lot of heat capacity, but not power consumption. So that keeps the water temp low. All right, so now on to tests. Now I have 2 tests. Sorry, I'm a bit sick today, but I have 2 tests to show you. Now, let's move this gimbal up a bit. All right, so let's give it a restart so we can reset all the numbers. And then, we will see what our numbers are. Yeah, it does look pretty cool. All right, so should be back up in 5 seconds or so. There we go. So I have 2 tests. One is a CPU test and one is a GPU test. And to get our baseline water numbers, so GPU idle 18 degrees Celsius. CPU sensors only. CPU is peak number right now while loading was 44 degrees Celsius, and then our third test temperature is going to be from the memory, which is, I'll pull it over here, is 18.5 degrees Celsius. So we're going to say that the water temperature is about 18.5, which is basically identical to the outside temperature. Our first test is going to be Cinebench R23, so we can do a full load on the CPU. Now I'm going to start the test. I'm going to pull up core temp, and there we go. So we're pulling 360 watts. Our peak temperature is at 79 degrees Celsius, 80 degrees Celsius, keeping consistent. Oh, no, we have another peak temp of 83 degrees Celsius. Now, the CPU needs a new lapping of the block and a new fresh gallium job, and I might sand the silicon as well. That would greatly reduce the temperatures since the water loop is already pretty good. So that was the CPU test, and our peak temp was 83 degrees Celsius, but those are pretty good numbers because I think in my previous video, with just internal water temp of like 33 degrees Celsius, we get up to like 103 degrees Celsius. So our second test is going to be Heaven benchmark, which gives us a full load on the GPU, but minimal on the CPU, so it's not gonna corrupt the water loop temperature. So now, we had an 18 degrees Celsius water temp, and we're sitting at 28 degrees Celsius peak temp on the GPU. So that is excellent. And that is basically all I had to show. So that is the end of the video. Thanks for watching, and yeah, those were all the upgrades that I've done in the last couple days. I might come up with some more upgrades, but I guess the next project's gonna be relapping and sanding the silicon and putting a gallium on there, and possibly sanding the blocks down to straight copper, and that should be the final like upgrade for the loop before the weather gets super duper cold. But stay tuned. Thanks for watching.